Hello everyone, welcome back to Cambridge Guru. As you know that we have already finished 10 chapters of pure math, component number 9709, paper number 32. And today we are going to start with the new chapter, and that is the last chapter, which is complex number. And I think this is the new chapter because you haven't studied, if you haven't studied the set portion of yours, if you haven't covered the set syllabus, then this topic will be new to you. Complex number is, as the word suggests, that it is complex, though it is not, because we say that the numbers are imaginary numbers. Sometimes we say complex numbers. Okay, so let us start. What do you mean by complex number? Suppose if I give you an equation which is x square minus 1 is equal to 0. This equation has 2 degrees, right? So you will get two solution. One is plus 1 and one is minus 1. So x is plus 1 and x is minus 1, right? But if I give you an equation x square plus 1 equal to 0, so using in this equation, since this is also a second degree equation, but you won't find any real solution for this. Logic is that if you this x square is always positive, and if you add a positive number to the positive number, the answer is always positive. You won't get a 0 because 1 you cannot do anything to this plus 1. So whatever solution exists, that whatever we have to talk about, that is a part of x square. So if I have to get answer as 0, so this x square has to be negative, right? But you know, as far as real numbers are concerned, that any number whose square you are finding out, that square is always positive, right? If you have a positive number, of course its square is positive, and if there is a negative number, then also its square is positive, right? So you won't find any real solution for this equation, right? Meaning you won't find any x whose square is negative, right? Similarly, in second way of understanding this is that if you find out the discriminant of this equation, if you know how to solve a quadratic equation using formula b square minus 4ac under root, means first finding out the discriminant and using that formula, right? So if you find out its discriminant, which is b square minus 4ac, and that discriminant will come out to be negative, and under root of that negative is not possible, so we say that you won't have any solution for this quadratic equation, right? But there is something which is called the fundamental theorem of algebra. Fundamental theorem of algebra says that if you have an equation of n degree, then it will have n solutions, no matter the solutions are real or imaginary, right? I have introduced the term imaginary, but I will give you later the meaning of this imaginary, right? So that fundamental theorem of algebra, if I apply in this equation, so it says that you will have two solution for this. Those two solution, as I said, that those are not real because you won't find any real values of x. So we introduce some another number system which is a complex number, right? So solution of this equation will have x which are not real, and we call those solutions as imaginary numbers or the complex numbers, right? So how we can find out the solution of this, or what are basically complex number, right? So the basic idea is that only that since under root of negative is not defined as far as real numbers are concerned, so we will pick that under root of negative something, and we will define or replace that under root of negative number by some imaginary number, and then we will be able to find out the solution. Meaning is that if I say that you have under root of minus 4, right? So as far as real numbers are concerned, you won't have any solution for this. But if I break this into under root of minus 1 and into under root of 4, right? This under root of 4 is of course real, and the value of this is 2, right? So it is minus 1 under root and into 2, right? That means if you call this minus 1 under root something, right, you will be able to find out the solution. And this under root of minus 1, this is called or is denoted by small letter I, iota we call this as, right? So solution of under root of minus 4 can be written as twice into I, right? And you will find this under root of -1, which is I, everywhere as far as complex numbers are concerned, right? So we have derived a new number system, right? I will talk the very basic, that since I have introduced this term number system, that this complex number is a superset of real numbers, right? If I give you the idea of this geometrically, because we will learn the geometrical interpretation of a complex number, but just for the time being, you just understand this, that if real numbers are concerned and we have to represent real numbers, then those real numbers are represented on a horizontal line, right? We call this as a real number line or just a number line which is horizontal. If it is horizontal, that means that is a one-dimensional thing, right? So as far as complex numbers are concerned, so those imaginary numbers are represented using two-dimensional plane, right? So one is going along the real number line and another part is going in the y direction, right? And a complex number is represented in a two-dimensional plane. We call that plane as an Argand plane or a complex plane simply, right? We will learn that later in the chapter, but for now it is the two-dimensional number system, okay? So that complex number is a superset of real number, and that complex number consists of two parts. One is the real part and one is the imaginary part, right? So normally we used to represent complex number by letter Z or Z, right? It will have a real part denoted by real number A, and it will have an imaginary part denoted by a real number B. This B is real. To make this as imaginary number, I need to multiply this by I, right? So I will call this A as the real part and this I times B, this is the imaginary part. Right? And remember that A and B, where A and B, they both belongs to real number, right? If I'm talking about this just B without this iota, this A and B have to be real numbers, and just multiply this one out of these numbers with I, that becomes an imaginary, right? If you're talking about B as is itself an imaginary number, that will become a real number. We will talk about it later, right? So just remember that I have this value of I as -1, right? So if I square this, you will get -1. I is under root of -1. If I square this, I into I, that will be -1, right? And if I again multiply this I square by I, that means I cube, right? So that will become -1 into -1 under root, okay? This is I cube, that means minus of I. So I cube is -y, and lastly I raised to power 4 is minus I into I, which is minus of I square, and as you can see that I square is -1, so this is -1 into -1 is +1. That means if I multiply this iota 4 times by itself, you will get a real number I or real number 1. Okay, so these 4 are the basic equation that you need to remember, that value of I is minus under root 1, I square is minus I square is -1, I cube is minus I, and I raised to power 4 is +1. Okay, so again I can write this, and this is I square, this is I cube, this is I raised to power 4, its value is -1 under root, this is -1, this is minus I, and I raised to power 4 is +1. Okay, just remember these. Okay, and any real number Z is denoted by A plus IB, right? A is the real part, and we say I into B is the imaginary part, where both A and B are real numbers. Okay, now since we have introduced the complex numbers, so now if you have been given a quadratic equation whose B square minus 4AC is less than 0, it is not greater than or equal to 0, then now you are in a position to find out the roots of that particular quadratic equation. right? So let us take one example to find out or how to solve any quadratic equation now, because for example, solve the equation z square minus 6z plus 58 equal to 0 and check the roots. Okay, so let us find out the roots of this equation using the quadratic formula. So solution is that z will be minus b plus minus b square minus 4ac under root divided by 2a, where the value of b is minus 6, so it will become plus 6, plus minus b square is minus 6 square minus 4a into 58. Sorry, this square root is here, right? And upon twice of a, which is 2 into 1. Okay, so this is 6 plus minus minus 6 square in bracket is 36, and this is minus 458 into 4 is 232, so minus 232 square root divided by 2, and this is 6 plus minus square root of minus 196 divided by 2, and square root of 196. Now you are in a position to find out its value just by writing this as 6 plus minus square root of minus 1 into square root of 196 divided by 2. Okay, so this is 6 plus minus I times and the square root of 196 is 14. So you will write this as 14I. Okay, this is I, this is 14, right? Divide by 2. So divide this by 2, you will get 3 plus minus 7I. Okay, now you have two roots. One root is 3 plus 7I and second root is 3 minus 7I, right? And please remember, complex roots always occur in pairs. Because why in pairs? Because here it is plus minus. Okay, you won't get any value that one is real and one is negative, because complex roots, if it is plus 1 plus 7i, then you will be able to find out minus also, because there is a negative sign also. Okay, so complex roots, please remember this, occur in pairs, right? So 3 plus 7i and 3 minus 7i, these are the two solution of this equation, right? So if you see here, we say that 3 is the imaginary real part and 7 is the imaginary part of first solution, and for the second, minus 7 is the minus 7i is the imaginary part of the second solution. Okay, thank you for this tutorial. We will introduce how to write a complex number in the form of real and imaginary part, okay, in the next video. Thank you.